Kinetic theory of gases. Basic postulate of kinetic theory of gases. Every gas consists of extremely small particles known as molecules. The molecules of given gas are all identical but are different than those of another gas. The molecules of a gas are identical, spherical, rigid, and perfectly elastic point masses. The size is negligible in comparison to intermolecular distance 10 to the power minus 9 meter. Assumptions regarding motion. Molecules of gas keep on moving randomly in all possible directions with all possible velocities. The speed of gas molecules like between 0 and infinity, very high speed. The number of molecules moving with most probable speed is maximum. Now, assumptions regarding collision. The gas molecules keep colliding among themselves as well as with the walls of containing vessels. These collisions are perfectly elastic. That is, the total energy before collision is equal to total energy after the collisions. Assumptions regarding forces. No attractive or repulsive force act between gas molecules. Gravitational attractions among the molecules is ineffective due to extremely small masses and very high speed of molecules. Assumptions regarding density. Density of gas is constant at all points of the container. Kinetic interpretation of pressure. PV is equal to 1 upon 3 m n square RMS. M mass of molecules, n number of molecules. Ideal gas equations. PV is equal to mu RT mu to n. PV is equal to mu RT, mu here n. P is equal to mu RT upon V, mu n kT upon V is equal to n upon V into kT is equal to n kT. Gas law. Gas laws. Boyle's law. For a given mass at constant temperature, V is inversely proportional P. Charles' law. Charles's law. For a given mass at constant pressure, V is directly proportional T. Gay-Lussac's law. For a given mass at constant volume, P is directly proportional T. Avogadro's law. If PV and T are same, the number of molecules N1 is equal to N2. Different speed of molecule. B RMS is equal to under root 3 RT upon M W is equal to under root 3 KT upon M. BMP is equal to under root 2 RT upon M. MW is equal to under root 2 KT upon M. B average is equal to under root 8 RT upon pi MW is equal to under root 8 KT upon pi M. Kinetic interpretations of temperature. Temperature of an ideal gas is proportional to the average kinetic energy of molecules. PV is equal to 1 upon 3 m NV square RMS. PV is equal to mu RT is equal to 1 upon 2 MV square RMS is equal to 3 upon 2 kT. Degree of freedom F. Number of minimum coordinates required to specify the dynamical state of a system. At higher temperature, diatomic molecules have two more degree of freedom due to vibrational motion, one for kinetic energy, one for potential energy. At higher temperature, diatomic gas has F is equal to 7. Maxwell's law of equipartitions of energy. Kinetic energy associated with each degree of freedom of particles of an ideal gas is equal to 1 upon 2 kT. Average kinetic energy of a particle having F degree of freedom is equal to F upon 2 kT. Translational kinetic energy of a mole is equal to 3 upon 2 RT. Translational kinetic energy of molecules is equal to 3 upon 2 kT. Internal energy of an ideal gas U is equal to F upon 2 mu RT. A specific heat Cp and Cv. Molar specific heat of a gas C is equal to dq upon mu dt. Cv is equal to dq upon mu dt. V is equal to constant. Du is equal to mu dt. Cp is equal to dq upon mu dt. dp is equal to 0. Cv plus R. Mayer's equations. Atomicity, translational, rotational, total F y is equal to Cp upon Cv. Cv is equal to F upon 2 R. Cp is equal to Cv plus R. Monoatomic HEARNA, translational 3, rotational 0, total F 3, y 5 upon 3, Cp upon Cv 5 upon 3 is equal to 1.67. Cv is equal to F upon 2R, 3 upon 2R. Cp is equal to Cv plus R, 5 upon 2R. Diatomic H2N2. Translational 3, rotational 2, total F 5, y is equal to Cp upon Cv 7 upon 5 is equal to 1.4. Cv is equal to F upon 2R, 5 upon 2 R. Cp is equal to Cv plus R, 7 upon 2R. Triatomic linear CO2. Translational 3, rotational 2, total F 5, y is equal to Cp upon Cv 7 upon 5 is equal to 1.4. Cv is equal to F upon 2R, 5 upon 2R. Cp is equal to Cv plus R, 7 upon 2R. Now triatomic non-linear NH3 and polyatomic. Translational 3, rotational 3, total F6, y is equal to Cp upon Cv 4 upon 3 is equal to 1.33. Cv is equal to F upon 2R, 3R. Cp is equal to Cv plus R, 4R. For mixture of non-reacting gases, molecular weight MW mixture is equal to mu1 MW1 plus mu2 MW2 plus upon mu1 plus mu2 plus a specific heat at constant V is equal to CV mixture is equal to mu1 CV1 plus mu2 CV2 plus upon mu1 plus mu2 plus a specific heat at constant pressure CPV. CP mixture is equal to mu1 CP1 plus mu2 CP2 plus upon mu1 plus mu2 plus Y mixture is equal to Cp mixture upon Cb mixture is equal to mu1 Cp1 plus mu2 Cp2 upon mu1 Cb1 plus mu2 Cb2 plus so on. Some important points: kinetic energy per unit volume. EV is equal to 1 upon 2 in bracket a small m into n upon v. V square Rms is equal to 3 upon 2 p. At absolute zero, the motions of all the molecules of the gas stops. The higher temperature and low pressure or at higher temperature and low density, a real gas behave as ideal gas for any general process. Internal energy change del U is equal to NCV dt. Heat supplied to a gas del Q is equal to NCDT, where C for any polytropic process, PV is equal to constant, C is equal to Cv plus R upon 1 minus X. Work done for any process. Del W is equal to P del V. It can be calculated as area under PV curve. Work done is equal to del Q minus del U is equal to NR upon 1 minus X dt. For any polytropic process, PV is equal to constant.